And if anyone has any problem with that, keep your cameras off. And we will then be sharing this information through the pages of PolyU, the Hong Kong Polytechnic University, and also through the ISGS Hong Kong pages. So if you're a member of ISGS Hong Kong already, we will be sending you an email. If you're not yet, I encourage you to join us to get more information about future events and obviously the links to all of these events. Because we have not asked you to register for this session, we do not have your contact details. So if you're interested in having a copy of the talk later on, make sure to email ISGS Hong Kong. That would be the fastest way of doing it. Okay, so I'll put the email address on the chat in a minute. So I think that's it for the presentation. I have muted you all because there was quite a lot of chatter before. So just remember that when it gets time to the Q&A, we will need to unmute you. If I forget to do that, send me a chat message. So, Dr. He, over to you, please.
Great. Thank you, Rainier. Thank you very much for the introduction and also for the invitation. I would like to firstly activate my screen sharing. So that's the most important, I think. Yes. And
believe it or not, we were checking this just before we admitted everyone, and it was working fine. So let me carry on telling you about Dr. He. Meanwhile, I had the pleasure of hearing him speak at the JESPIN conference this summer, and that's why he's here with us today, because I thought his work was really interesting, and it would be great to have him talking to the Hong Kong ISGS audience. So yeah, we could see it, and it's just gone away.
Yes, I see, because I was still at the page where we just tested the slides. I didn't start from the beginning, so I would have to restart again. Okay. Oh, it's by share screen, and now here we are.
Okay. Yep, we can see
the title. Yes.
Yep.
Okay, great. Thanks everyone for coming. I see a lot of names and little hands here. Thanks a lot for coming at this such a late evening time. So my name is Yifei He. I'm very happy to give this talk today on some of my research about the relationship between speech and gesture, mostly from the processing perspective. So the talk the name of my talk, the title of my talk today is called The Effect of Cold Speech Gestures on Speech Perception and Language Comprehension. So from the title, it becomes obvious that I focus mostly on how people comprehend gestures together with speech. So I know, I mean, in the gesture literature, production studies is very predominant, but unfortunately I've never done any research in production, so I can only contribute my little part from this aspect. So when you talk about the interaction between gesture and speech in comprehension, so we mostly talk about two things. So firstly is that how our human brain can integrate the complex information from speech and gesture into a very coherent concept without any effort. So this is one part of the process that is very interesting, because if you consider how complex this process can be, this is actually very, very interesting. But unfortunately today I'm not going to cover this part of the research. I'm going to talk more about something that we might be more interested in, that is how potentially gesture helps us or potentially doesn't help us to process language. So that is, for example, what potential facilitative effect that we get additionally from a gesture channel whenever we hear others talking only with speech. So that is what the line of research that I'm going to talk about today is mostly about. If we have a speech which is presented in a visual form or in an auditory form, and then additionally a speech plus the gesture, and then what potentially the effect of this gesture is about on our comprehension. And that's going to be the main focus of the study of my talk today. And I think something is wrong. Okay, yes. So I'm going to cover 3 aspects of studies that that I did in the past few years. So firstly, I'm going to start with a study which looks at the relatively peripheral situation, which is the social aspects of gesture. How could this have an impact on speech comprehension or language comprehension? I think this is a very minor point. This is why I termed it peripheral here, but maybe, I mean, it echoes some of your research interest, and we'll see that. And then the later two aspects comes more about how gesture impacts semantic processing at different levels of speech. Firstly, about how it have an impact on the processing of long passages. So whenever we hear a long paragraph, how having a gesture might help us to understand it. Or in a more fine-grained dynamic manner, that is at the single word level, how gesture helps us to understand speech. I'm going to go into the details of this separately. Oops. Okay, so I will start with the first topic. That is a relatively peripheral situation, a social impact of gesture. As we can see, gestures, and also maybe all of us already know that gestures in general facilitate language processing at a semantic level or at different potential level. So there's already a lot of studies about that. And most of the studies come from the behavioral perspective. That is, the reaction time word processing is going to be faster whenever an additional gesture and channel is presented. But for most of the studies, there are things that people ignore. It is which features of the gestures can facilitate or potentially inhibit speech or language processing. So for example, we can say that when we talk about different types of gestures, maybe having an iconic gesture would facilitate language processing more, and having only a beat gesture, which doesn't have any semantic meaning, doesn't facilitate language processing that much. So this is already a very established line of research, and there's already some colleagues contributing to this research. And also we could also hypothesize something like the amplitude of gesture might also have an impact. I don't think there's empirical research in this line of research, but we can assume that, for example, if we talk about something that is very big, so with the amplitude of gesture with very large versus something that's very big with the amplitude of gesture with very small. So these two types of gestures, even if both of them are iconic, they're referring to some very concrete aspects, but the way that they have an impact on our concept big could be also potentially different. This is also an aspect that has been actually ignored in the literature. Please correct me if I'm wrong. Okay, and in this study that I'm going to present is about something that is seems to be very trivial. That is about the gesture orientation. So I'm going to show something like a gesture here. So if a person who's talking to you, not facing you directly, but facing you in a lateral manner and then producing a gesture. And then maybe what you are going to think about is, okay, is this guy gesturing to me, right? So this is something that could be very likely. And also when this person is talking about the gesture and then at the same time also producing some speech. So the meaning of the gesture definitely has to coincide with the speech. And then the question is, does this type of co-speech gesture, not facing you, have an impact on language comprehension in a way which is similar to the more addressed gesture that is directly facing to you? Now, this is a very interesting question when we conduct this study at the beginning, because at that time, there's already some literature in the field which shows that really the social aspects of gesture may already have some linguistic consequences. So there's one line of research from our colleagues in Nijmegen, from James Trullo, who showed us more social gestures actually help us more with the processing of the semantics. And also in our own lab, we also have in an fMRI study, we show that when you're facing the participant versus when you're not facing it, the way that you comprehend these gestures are different. So then the question is whether these two gestures makes a difference or not. This is a very interesting thing. Even if in the real life situation, we rarely see someone gesturing to us not facing us. I guess that's how it is. Okay. So for this purpose, we set up a very artificial environment. We tested with a very, very conventional paradigm that is called cross-modal priming. The paradigm is very straightforward. It looks like this. So here the panel C shows a sample trial. So it starts always with a fixation mark, and then it shows a gesture video of 5,000 milliseconds, 5 seconds, with a person showing the gesture without saying anything. And then after the presentation of the gesture, it comes with the sentences in the word-by-word RSVP manner. That is, for example, here the sentence is, the fish is very small, thanks Lara. Okay, so at the position of the gestures, we manipulate the gesture in two different ways. So we presented the gesture in a completely frontal way, which is addressing to you. In this case, it's an iconic gesture showing large or big, like this. And then we also have, so when we recorded the video, we have a lateral perspective. So we recorded exactly the same gesture, but presented it from a lateral perspective. So the person is not facing you, and the gestures is being presented in a more lateral way. The same type of gesture, exactly the same motion, everything, but only differ in terms of the orientation. And then after that, because here we see this, the sentence, the gesture is showing something that is large. So we present the congruent sentence, the fish is big. And also we present the sentence, incongruent sentence, the fish is small. So if you have some ideas about the ERP literature about language processing, then if you see a large gesture followed by the fish is small, then you're going to expect something called an M400, which is the neural correlate of semantic anomaly detection. So what our hypothesis is that, I will probably ignore this at this moment, at the position of the critical word, which is big versus small, whether presenting a frontal gesture or a lateral gesture will have an impact on this M400 component. This is very simple. So if potentially the social aspects or the orientation of gesture have an impact, then this modulation is going to be changed. And at the same time, we also look at another thing, which is called the alpha and beta power decrease during the gesture presentation. So this comes from another line of literature showing that so whenever you process a gesture, your brain signals in the alpha and the beta power is going to decrease. So we're going to see whether exactly the same action or gesture is going to be showing different alpha power decrease during the observation of the gestures. So in this study, we focus at two different time windows. Firstly is only the observation of the gesture videos. And secondly is the processing of this word that is going to be congruent or incongruent with the gestures. And then that's it. Okay. So here, the first slide shows us the result, time frequency result when you process your gestures. And this is for the frontal gesture. This is the lateral gesture. 0 is the onset of the gesture of the video. So as you can see here, the difference between around the beta and alpha power actually really differs between the frontal and gesture and lateral gestures. So which means that even if these gestures are exactly the same as each other, they're going to be actually differently processed in the brain. And this difference is going to be reflected in the alpha and beta power decrease. And we also source localize this power difference in the source space. And we found that, okay, it is actually a place called the medial prefrontal cortex that makes this difference. This region is very, very important because it is one of the de facto regions for processing social information. So this means that both types of gestures represent different types of social information, and these are reflected in the alpha and beta power source localized to the medial prefrontal cortex. So this is only about the perception of the gesture per se, but it's not about how gestures have an impact on semantic processing. So this is the result at the position of the critical word, where the word is big or the word is small in comparison to the context showing the iconic gesture. So the left-hand side shows all the results for the frontal gestures. So the red line is the incongruent condition, the blue line is the congruent condition. So as you can see here, around the central parietal electrodes, there's a fairly large difference between the two congruent and incongruent conditions. That is one of the most classical N400 effect that we can see in the literature. So this is when the gesture is presented in the frontal way. But if we look at the laterally presented gestures, across all of the central parietal electrodes, there's no difference between incongruent and congruent, which means that even if you're still presenting this lateral iconic gesture at the position of the critical word, which is big versus small, your brain didn't process it, this semantic anomaly. So this is very interesting because it shows that the semantic congruency N400 was simply modulated for the lateral gestures, which were, from our perspective, very, very similar to the lateral ones, to the frontal ones, but I mean, actually, they have a different impact on the upcoming semantic processing. Okay, so this is all for this study. It's very straightforward, very simple. And I think this shows a very social aspect of gesture, and also together with the multimodal language processing. So from this result, we see that, okay, some aspects of gestures, maybe we call it social aspects, we call it body orientation of gestures, they can be perceived and reflected in the brain. So the way that they're perceived is different, as seen by the beta band power decrease. And we see that the difference is being reflected in one of the most social regions. And most importantly, they have an impact on sentence level semantic processing. That is even more interesting. But after we get this result, we also found that there are some other very similar studies also showing social factors on language processing. They are not using exactly the same gesture manipulation, but they all show that language processing model requires the inclusion of social aspect into it. For example, in this paper from Juraflov and Fedorenko, what they did is that they asked participants to see typical N400 manipulations on paradigms. So they asked participants to sit there alone versus sit there together with another participant. So what they observed is that when you sit there alone versus when you sit there together with another participant, the N400 that you elicited from this semantic anomaly is actually also modulated. So this, even if they use a very different paradigm, so this shows something that is similar. That is, our semantic language processing system is not entirely encapsulated. It can be subject to influence from the top-down social influence, but these types of empirical evidence is still sparse at the moment. And also, to my knowledge, even at the moment, not a lot of the language processing models have put the social aspects into it. Yeah, but the good side is that there are already quite a lot of colleagues who are working towards making more fine-grained characterization of how to really model this effect. So I'm just looking really forward to the upcoming studies. Yeah, but also, as you can see, for this study, we use a very, very conventional paradigm that is, I would say, probably from the 80s. So the gesture and the language stimuli were presented completely in the isolated way, one after the other, which is totally arbitrary and artificial. So the critique would be, what if the paradigm is more natural, in the more naturalistic co-speech gesture situations? And this is actually the direction that we are going to work toward in the future. But you can imagine if we design the comprehension studies with a lot of very natural gestures, some are facing you, some are not facing you, this can be also very complex. So this is a really tough work, and then we hope that you could also share some ideas on how to implement this in the future. Okay. So after I talk more about this peripheral situation, I'm now going to tackle the more hardcore stuff, which is the thing that I've been investigating for quite a long time. That is how gesture impacts semantic processing, really the semantic processes. So I'm going to show it from two aspects. Firstly is that how the processing of long passages can be potentially influenced, either facilitated or inhibited by gestures. And the second is on single word level, how fine-grained single word mechanisms can be also impacted from gestures. Still the same research questions at very different levels. Look at it, high, much longer phrasal level, much shorter word level. You can imagine if we want to investigate these processes, we need to set up a lot of experimental stimuli. We have to create a lot of sentences, different words. There's going to be a lot of work. For those who have worked with gesture stimuli before, a lot of annotations, a lot of effort. This is going to be very, very difficult to test in different separate experiments. So one way to account for this type of complexity is to approach these research questions by a naturalistic and multimodal approach, which is that we present to participants a very, very long story. A person telling you a story like I'm currently doing at the moment without any stop, doing different type of gestures. Some are relevant, some are totally irrelevant. Yeah, I don't know. And we don't do any experimental manipulations. What we need to do is that we parameterize the gestures, we annotate them. We also parameterize our speech, which can also be parameterized in very different, interesting ways. And then we do the analysis. So in this way, we can only run the experimental paradigm for once and then collect either EG or fMRI or behavior data, and then we can do a lot of the new analysis based on that. So that's the approach that I'm going to talk about for all of the upcoming studies. Actually, this is not new already for language researchers, because if you take a look at the language researchers, the processing of narratives has been really predominant since the last 4 or 5 years. But regarding the multimodal language narratives, I think even at the moment, only a few labs, for example, Gabriela Villioco's lab and us, we are probably the only labs who really look closely at the comprehension from this perspective, but we look at the same stimulus from different approaches. Okay, so I'm going to show you firstly the stimuli that we show to our participants. This is German, so for those who have potentially maybe some German knowledge, it would be more interesting.
Samir war ein armer indischer Junge, so arm wie der Staub auf der Landstraße. Wohnte in einem der kleinen sandigen Dörfer am Ufer des Ganges zwischen Mandalay und Prom. Seine Arbeit.
Okay, it's very short because it's only the very starting of this long story, which lasted 30 minutes. So here on this side is the translation. So Samir was a very poor Indian boy, as poor as the dust on the highway. So the text which is underlined shows that where there is a gesture. So here the dust on the highway is something like this. And then he lived in one of the small sand villages on the banks of the Ganges. I don't know where it is, between Mandalay and Prog. I think this is a deitic gesture showing between here and here. So in this very little excerpts, there are 2 gestures and there are lots of words. So altogether, within this 30 minutes video, we have entirely the story which have more than 3,500 words. And altogether, our genius actor produced 400 gestures of different types in a completely spontaneous manner. So they're all very naturally made. And then I can make sure that really all of the participants like to attend this experiment, because it's just a lot of fun. Okay, so after you presented this story to our participants, we need to test this. So firstly, what you can think of is that how to do it, right? So how exactly can we test this? So now remember, the goal of this current research is to test the processing of semantic processing with long passages. So if we bear in mind, this is our objective, we have to really cut down our story into different passages. So what we do is that we cut this just in the level, in the units of 10 words. And then we collected fMRI data based on this paradigm. And what we do is that we calculate something based on this little 10-word units. What we calculate is called the semantic complexity in terms of idea density. I don't know if this is a concept that is known for some of the audience here. It's a very common concept that is used in clinical settings. The calculation is very simple, actually. So it just calculates how many propositions or how many ideas a block refers to. So for example, if a sentence talks about a lot of new topics, then the idea density can be very high. If a passage talks about only a few idea density, a very low idea density, then the numbers of ideas that is referring to is very low. So this is a very simple measure of measuring the semantic complexity of these long passages. So what we did is that we split the story into 10-word passages, always 10 words, so that they can, it's more arbitrary. And then we calculate the idea density, and we split them into high idea density versus low idea density parts. And if we compare the fMRI signals here between this high and low, we can get a processing in the brain, which shows that how you process the high idea density passages, which is a reflection of your brain process of processing the semantic complexity of long passages. And then on the top of that, for each of the passages, we calculated how many gestures were being presented at the same time. So for example, in this very first video that I showed you, maybe within these 10 words, there are 2 gestures that have been presented. Okay, then we just count this number as 2. In some passages, okay, maybe it's so boring that our actor didn't produce any gestures at all, then we count it as 0. So in the end, we come up with passages that are coded as only 0, 1, and 2, or even more than 2. I think there are only very, very few passages with more than 2 gestures, because you see, you have to produce a lot. Okay, then the whole experimental stimuli is being cut down into segments based on the 2x2, 2x3 design, which is high density versus low, times how many gestures were being presented. So we can analyze this data in a way that we potentially are very familiar with. And what we're testing is, firstly, how high density versus low density idea density is going to be reflected in the brain, and additionally, how gesture potentially has an impact on that. And the result, firstly, for the main effect of idea density is that if we compare both passages, we have an activation. For those who are without brain imaging experience, it might be more difficult to interpret. But here we have a very typical activation, which is called the default mode network, comprised of the anterior ACC and the precuneus, which is usually there when you are not doing anything, this is why it's called default mode network. So we observe that for the low idea density passages, which is the complexity is low, you activate this default mode network more. So which is more like a proof of concept, which means that if you process more semantic ideas, then this activation of this default mode network is going to be decreased. And then if you don't do it, then this is going to increase. This is not very interesting because it doesn't have any indication about gesture. So whenever we look at the gesture times idea density interaction, we found an interaction in the left hemisphere, which is the middle temporal gyrus, which is one of the classic regions for processing languages. And for this region, if we look at how exactly the pattern is, we can find that only for the high density idea density passages, whenever we present no gestures, which is this long bar here, its activation is very, very high. So as long as we presented 1 gesture or 2 more gestures, the brain activation in these 2 regions all of a sudden reduced. So that's the effect that we found only for the high density segments, but not for the low density segments. So this is an indication that whenever the semantic load of this passage is super high, gesture helps to reduce the brain activation in a typical language region. So that can be considered as some potentially facilitative effect of gesture on the neural processing of long passages. Okay, just to sum up very quickly. So we see that low idea density passages activated the default mode network. And more importantly, we see that gesture reduce the processing demand for the higher density passages in the left medial temporal gyrus, which is a very typical language region. So based on this, we see a neural facilitation of gestures on the long passages processing. Okay, So here we have some ideas using fMRI, which is a very slow measure on how your brain processes long passages, and then how this can be potentially facilitated by gestures. But as someone who is more interested in a very fine-grained linguistic phenomenon, what I'm more interested is about what about the fine-grained dynamics at the single word level, because a single word level provides us with the fine-grained granularities about how your brain processes languages. So in this case, probably if you have an idea about how different fMRI and EEG is, you can see that, okay, if you're measuring single word in this long segments, probably you should go with the EEG experiments. And this is exactly what we do. So we take exactly the same stimuli, and then we collect the EEG data, and we run the study. But then the problem is how? How do we set up a study based on this paradigm? I think that's a more interesting question. So here we still have the same story, still have this 2,500 words. We still have these 400 gestures. But the question is, with EEG, what should we do? At single word level, semantic process can be even more complex, because if we look at the literature, it provides us already with a lot of studies. For example, some say that, okay, N400 reflects the retrieval of a single word, if it reflects the prediction of the upcoming word, or it reflects the integration into its preceding context. All of these are theoretically very relevant and important. Yeah, but the problem is that at the moment, there's no study on how gesture have an impact on all of these fine-grained processes. So what we need to do is we need to find some measures that reflect all these different levels of processes. Regarding retrieval, for example, it's very straightforward. Usually, whenever you process a high-frequency word, you would say the retrieval would be easier. Whenever you process a low-frequency word, you would say that the retrieval is more difficult. So in this case, the single word frequency would be a potential measure of semantic retrieval cost. This is more straightforward. But what about prediction and integration? So this is actually more dynamic. I will probably start with a very straightforward sentence showing two very important aspects about prediction and integration in semantic processes. So here I have a sentence which is called, for breakfast, I eat. At the position of eat, I can guess what the next word is. So here there's an illustration of what I could eat. Some are more likely, some are less. For example, you can eat a yogurt, which is totally correct according to the European English tradition, but not actually possible for Chinese, because you have to drink. But then at the position of eat, the amount of possible continuations that this word has is referred to in the literature as a notion called entropy, which refers to how much sure or unsure you're about upcoming words. So if you have a lot of possibilities for the upcoming words, in this case, for breakfast, I eat, then the entropy of this eat is going to be very, very high. And if you don't have any other alternatives, for example, you have another sentence like, in the North Pole, I see a polar. At the position of the polar, I guess you only have one or two options: polar bear, polar fox, and then that's it. In this case, the entropy is going to be extremely low. So the notion of the entropy refers to how predictable or how unpredictable you are about the upcoming context. Okay, there's another very important aspect. So here we have still the same sentence, for breakfast. And then I have, I eat a screwdriver. At the position of the screwdriver, you're kind of surprised, right? It's very unexpected. I mean, in the classic literature, we call it semantic anomaly, but in the computational notion, this level of surprise is expressed as a term called semantic surprisal, which shows you how expected or unexpected this current word is given its context. In this case, a screwdriver in a breakfast setting is totally unexpected. So the surprisal would be really, really high. But if you hear, say, I eat an egg, then obviously the surprisal is going to be very, very low. So for each of these words within this 3,500 word story, we could always measure some measures like this with some computational measures. It's actually quite simple. If you like, you can, I mean, we can discuss this in the later discussion sections. And also on the top of that, we also can measure directly the frequency for each word. So if you can assume that based on these measures, if we measure the potential relationship between frequency, entropy, and surprisal to our brain signals, then you'll get the different brain signals that reflects these different aspects. And additionally, on the top of that, whether having a gesture changes any of these relationships or not, it's going to give a relationship, it's going to give an index on whether gesture helps you to predict, whether gesture helps you to solve the integration problem. So that's the basic idea of this study. Okay. I think I will skip this. This is just about if we have 3,500 words, each has a value, we can cut them into high versus low, which is exactly the same type of analysis that we did for the long passage studies. But for a more scientific approach would be direct to run a regression analysis to see how surprisal fluctuates with, for example, the M400 or not. And okay. So now we talk about a lot of things, always without gestures, because we have to, based on, you know, the insights from those studies who only look at unimodal language processes. And if we run an EEG study, M400 would be definitely the de facto neural correlate that we should look for. And based on the very lab setting, there's already literature about M400 is being related to lexical retrieval, which shows that high frequent word is going to have less M400. It's going to be related also to semantic prediction, and also it's being related to semantic integration. So this is totally insights from the very controlled experimental settings. But in the more naturalistic approach of the language studies, there's already also studies already show that M400 correlates very, very nicely with lexical frequency. This is already a very established line of research. And also M400 reflects the surprisal. I think it's not a surprise. Then the higher the surprisal a word is, the higher the M400 it is. So only these two have a neural correlate in the EEG signals. But regarding entropy, which is another measure that we just mentioned before, in the literature, there's no consistent evidence about whether or which EEG index reflects that. So we didn't look at entropy in these EEG studies. And then because now we have additionally a narrative which have the words that are covered with gesture versus the words that are not covered with gesture. So what we want to test is that whether having a gesture can modulate the frequency M400 relationship, or whether having a gesture can modulate the surprisal M400 relationship. So we still have the same story, but we code our words differently. So for each of these words, Samuel stayed 3 days and 3 nights on the hills, we calculated the surprisal of each word, we collected EEG measures, and then we run, this is a very complex flow chart, but we can understand this as a regression analysis. So we want to see whether lexical frequency and surprisal have a neural correlate in the EEG in the M400 time window. And additionally, we split all of these words into the blue one is the words that are not covered with gestures. The red one is the words that are covered with gestures. And we code them as either 0 or 1. So we also put this 0 and 1 in our regression model, and we want to see whether including this coding versus not including this this coding could improve our linear regression models. And if this gesture information is helpful, then the overall performance of our linear models is going to be improved. And on the other case, if none of this coding makes a difference, then it shows that maybe the gesture doesn't help that much. So that's the way that we analyze the data. So we firstly do a model comparison. So we set up two lines of models. Firstly, without any gesture codings, no 0 and 1. The second is with gesture coding with 0 and 1 for each word. And then for each word, we have additionally one surprisal, one frequency predictor, one surprisal plus frequency shows the summation effect, and the surprisal plus frequency plus their interaction. So here we've created 2 times 4, altogether 8 models. And we want to see which one have the better model fit. And then additionally, we split the entire words into 2 different segments. One is no gesture, one is with gesture. And we directly compare them between each other, and we see whether surprise or frequency gives an effect or not. So these are 2 different sets of analysis, but the directions are already very, very similar. So here is the result for the model comparison. So, I mean, all 8 models, the higher number here indicates the better model fit. So as you can see, whenever we code our gesture, the model performance is always better than the models that we don't code the gesture, which is an indication that, okay, for these predictors, really having the gesture information helps to improve the fit between the models and the predictors and the EEG signals. And between all of this, we see that the frequency model actually has the best model fit, which potentially indicates that gesture helps to facilitate lexical retrieval, which is the frequency effect, more than the other predictors, like the surprisal. Yes. Then we do a direct comparison between the gesture absent and gesture present segments. So these curves, they are no longer the raw EEG signals. They are the regression coefficient between our predictor. Here, this is for the frequency at each single time point in the central parietal regions. So we see that here, if we see the blue line, which is talking about the gesture absent condition, you get more or less between the 3 to 500 milliseconds, a negative going peak, which looks more like a M400 effect. And if a gesture is present, this effect is gone, which is an indication that for frequency effect, which is the lexical retrieval effect, gesture helps to retrieve a word better. But we only have this from the neural perspective because we don't have a behavioral data with these paradigms. So this is for the frequency effect. For the surprisal effect, something actually is very similar, but it's not as, the effect size is not as large. It's still significant. Also potentially shows that this semantic integration can also be facilitated by gestures. This reduction of the M400 is different from the one that we previously see for the frequency effect, because frequency effect and the surprisal effect, they reflect 2 different levels of processes. One regarding lexical retrieval, the other is about the processing of your unexpectedness. And okay, that's for the EEG. We actually, again, also test this with an fMRI setting, which is from exactly the same logic. For fMRI, what has been established in the literature is also something firstly regarding to lexical frequency. So for example, the left IFG, inferior frontal gyrus, has been shown to be related to the processing of low frequency words. And regarding semantic prediction and integration, now you see a word which is called entropy. This is a very nice study from Roy Williams from Nijmegen, based on unimodal narratives. What they see is that these regions, this colored as red regions, angular gyrus, and also the more medial prefrontal cortex, they are responsible for making the predictions of the upcoming word. And these blue regions along the middle temporal gyrus, they are responsible for processing the semantic unexpectedness, which is the surprisal effect. So these were all based on unimodal speech-only stimuli. And now what we have is that because we have additionally a gesture manipulation, so we want to see still the same logic, whether having a gesture changes anything here, or whether having a gesture changes anything here. So that's the logic. So the way that we parameterize our different words is going to be different. So we still have the lexical frequency for each word. We still have the surprisal, but additionally here in fMRI study, because there's already a very established literature on the entropy effect, so we also put in our entropy as a predictor. And additionally, we put some control measures because fMRI signal is very slow. It's very sensitive to low-level activations. So we put auditory envelope, which is about how loud each word is, or a hand movement envelope, also into these models, just to control for a better result. And in fMRI, still the same regression analysis is called parametric modulation in SPM term, but still you can understand this as a regression analysis, and then that's it. Okay. So let's come to the result. So firstly, the frequency result. So this is the established result in the literature using single word. This is our result on the frequency. Very nice activation of the middle temporal gyrus and the left inferior frontal gyrus using a very naturalistic stimuli. So we directly replicate the left IFG activation for processing more low frequency words. So this is clustering all words that are with gesture versus without. So this is just a proof of concept. And then if we look at different words, whenever there is no gesture presented, yeah, the effect is still as strong. It's not surprising. Then low frequency word activate these regions. But whenever a gesture is presented, all of a sudden the activation decreased. And this can be shown also by the interaction analysis. That is, whenever a gesture is presented, the activation in these inferior frontal gyro cortex is reduced. And here we have a very, very good result, which shows that the presence of a gesture really modulates the frequency-induced left IFG activation. So the language areas that is responsible for processing low-frequency word actually is being facilitated by having additionally a gesture. And if you still remember our EG finding, this actually goes very nicely with our EG result, which also shows a facilitation effect of gesture on frequency. So combining both of these, we have an evidence of a neural facilitation of gestures on lexical retrieval. This is the result I like the most. Okay, now let's go to a more dynamic measure, which is entropy and surprisal, which is firstly about prediction. Surprisal is about integration. This is our result from this is the result from the Williams literature, and this is our result. I'm sorry for the very messy color coding because we use the blue exactly the same as their red. We use the red exactly the same as their blue. But if you compare this to entropy effect here, middle prefrontal cortex, angular gyrus, middle prefrontal cortex, angular gyrus, left hemispheric, exactly the same. Also, the surprisal effect in middle temporal gyrus, almost the same. For fMRI literature, this type of replication is usually very, very rare, but we directly replicate what the result using a very different stimuli, which is totally, we're very happy about this. Okay, until this moment, we still haven't touched anything about gesture. Unfortunately, whenever we want to look at the surprisal effect, we didn't find any interaction effect. You know, that's how it is based on the data. But for entropy effect, when we compare the gesture segments versus the non-gesture segments, we found a very clear reduction of activation whenever a gesture is presented. So that's the areas for the interaction. So you see here, middle prefrontal cortex, angular gyrus, these regions always show reduced activation whenever there is a gesture being presented. We call these our keywords. So that is when gesture is presented. All of these regions show reduction of activity, which could be interpreted as a neural facilitation of gesture on the prediction of the next word. So the brain, whenever you want to predict the next word, whenever a gesture is being produced, then the brain needs less resources. That's how to, interpret this result. Okay. So to summarize, so based on EEG and fMRI, we all together find very converging evidence on the neural facilitation of lexical retrieval, which is the frequency effect. And after we found this effect, I'm not an expert in production, but then I realized that I searched a little bit on Google. I see, oh, whoa. So the gesture facilitation effect on lexical retrieval in production is actually extremely established. So I think, okay, this from maybe we contribute to this line of literature from a more comprehension perspective. And regarding semantic prediction and integration, which is entropy and surprisal, the result between fMRI and EEG are not very consistent, but we still find some facilitative effect. For fMRI, we find a facilitation of semantic prediction with entropy. For EEG, we found a semantic facilitation of integration, which is surprisal. But what is unknown here with this paradigm is that at the moment, we still haven't tested anything about, for example, the lower level features of speech. This is our ongoing work, and which is going to be conducted in the future. So we're going to work like the phoneme level prediction and prediction error, and also the syllabic level prediction and prediction error. Because as long as we collected this data already, and then as long as we find a good way to model, to parameterize our phonemes and syllables, we can always compare whether gesture have an impact or not. And also one of the problem with this paradigm is that here we're still presenting participants in narratives. And as some people would say, yeah, narratives are still not very naturalistic, because in the real life, you would never listen to someone talking to you in 30 minutes and without responding to anything. So people are saying, yeah, maybe one should look more at conversations. At the moment, we don't have data on conversations, but I think this is a very good direction to go. Yes, you may have noticed that I haven't mentioned anything here in my talk today about gesture category. This is more due to the fact that this is more like a naturalistic setting. So the numbers of categories between each category is going to be very different. And also this type of analysis requires a large numbers of data points. And if we really split them into smaller fine-grained categories, then we don't have enough data points to go with this type of fine-grained analysis. But if you are still interested, for example, looking at how iconic gesture versus speech gesture had an impact, you can refer to the studies from Gabriele Biliocco's group, or the second one, Florian Hinz from Judith Holler's studies. I think I would just skip this. We can discuss about this in the discussion. The last thing is we haven't actually measured the gesture-speech relationships. That is, you can actually find a good way to measure how gesture and speech matches each other. This is actually very up-to-date and I think fashion topic now for this AI-based thing on multimodality and multimodal AIs. And based on this, we can actually leverage a lot of the methods that are from these multimodal AIs to really measure the congruence between gesture and speech. And then we can use these measures as a predictor to predict our EEG or fMRI signals. We are on our way to going towards this, and I presented one of the studies in Nijmegen, actually, but so if you are also interested in this aspect, you could contact me later on. Okay, I think I'm over time. It's already 50 minutes. So outlook, I'm going to go very quickly. So the current understanding of how gesture actually facilitates or inhibits speech process, language process is very, very far from satisfactory. And I would say it requires a very difficult and also a lot of fun multidisciplinary effort. So for example, one thing that we should focus maybe further on is which categories are different, which categories matter, which categories don't. And also if we can also provide some features of these categories, then maybe we can also run a similar regression analysis. And also regarding the paradigm, as you can see here, I presented two different lines of research from the two completely different perspectives. One is 80s, very conventional priming. The other is naturalistic. I'm not against any of this, and also I'm not pro any of this. I think that they have to be really go aligned with each other to test very different hypotheses. Both of them are very necessary. As I also mentioned, so now here we only have narratives, 30 minutes, always bombarding with a lot of gestures and speech. Maybe conversations would go provide us with some more insights. And also the last thing is that this is something that people usually don't look at, is the social aspects of multimodal language. For example, whether you're facing you or you're not facing you have an impact in language processing. This should be considered, as I have seen from the very first study that I presented today. The last thing that I'm going to mention is that most of these are basic research. But for gesture studies, as maybe you are working on also developmental studies, also the impact of gesture on learning. In our own lab, we also work at the processing of gesture in patients with mental disorders like schizophrenia and depression and bipolar disorders. And most of these are extremely interesting, and also they really have the real world application value. So if any of the audience today also come from this background, if you want to apply some of these applications, I'm very happy that we can be in contact. Okay, so that's all for today. I'm sorry I'm 3 minutes longer than expected, but thank you again for being here, and thanks Rainier again for inviting me. It's a great honor.